So, this PowerPoint is on percent yield. You're going to have to calculate percent yield. So we went through stoichiometry, we went through the limiting reagent, we went through empirical and molecular formula, and now the last step is percent yield. As in limiting reagents, it goes hand in hand with percent yield. How to identify a limiting reagent problem, just a refresher. The information is given for 2 reagents. How to identify the percent yield problem, information is given to 1 reactant, which is the reagent side of the equation, and 1 product, so you know how much you actually are calculating. It says percent yield, so what do you think you have to do at the end? Move it into 8%. Percent yield equals actual yield, which means the actual value you get divided by the theoretical yield, what you were supposed to get by doing the limiting reagent calculation, times 100, and that's your percent yield. Think back to math class, how you had to change decimals into percent. Same concept. Calculated using stoichiometry, limiting reagent, measured in lab. So what do you think the next week and a half is going to be? Nothing but labs. Don't worry, you only have 1 lab report though. So, when 45.8 grams of K2CO3 reacts with excess HCl, 46.3 grams of KCl are formed. Calculate percent yield. Remember, you always have to first do your balanced chemical equation. Go in and write this balanced chemical equation for your answer to turn in. This is number 1. Write this equation. K2CO3 plus 2HCl yields 2KCl plus H2CO3. Oops. Whoa. Sorry. Okay. So how do we start? We start by writing what we have, what we know. We have 45.8 grams. We have KCl. 46.3 grams are formed, reacts with excess HCl. So we know that this is our limiting reagent because remember the excess does not limit, but the limiting reagent limits, which is 45.8. And so we have 46.3 grams of KCl are formed. Calculate percent yield of KCl. So how I would do this is I would set up my equation, 45.8 grams of K2CO3. Then I would change that to moles. I would do, where's potassium? 39.1 times 2, so 39.1 plus 39.1 plus 12.01 plus 16 plus 16 plus 16 equals 138.21 grams per 1 mole. My grams cancel, I'm left with moles of K2CO3. Then remember that the mole to mole ratio. 1 is the coefficient, so I have 1 mole of K2CO3 over 1 mole of, 2 moles of KCl. Then I changed it to grams. How do I do that? I changed 1 mole down here. I go K, which is 39.1 plus 35.45 equals
Repeat that.
35.45 plus 39.1
34.45.
is what? 74?
73.55.
73.55 grams. Now take 73.55 times 2 times 45.8
67.30.
divided by 138.21
138.5
equals
48.64.
48.64 grams. And this is my theoretical. Now I take my actual right here, which is 46.3 grams, divided by my theoretical, 48.64 grams. Grams cancel. So I go 46.3 divided by 48.64 times 100 times 100 equals 95%. So my percent yield is 95%, which is really, really good. Now everyone got that in one try? Let's try it again, but this is number 2 in your notes. Write 95% down. Okay. Now we can move on to the next problem. Calculate the percent yield for the production of carbon dioxide gas at 18 grams. I go ahead and circle what I have. 18 grams of sodium bicarbonate, which is right here. Produces 5.6 grams. This is what I measure in the lab of CO2, so this is what I'm after. I notice right off the bat that my coefficient is a 1-to-1 ratio. I'll know this for further, but first I have to convert sodium bicarbonate into moles. So it's 18 grams over, I look at the periodic table, my formula is Na, which is 23 plus 1 plus 12.01 plus 48 equals
64.01.
64.01 grams per 1 mole. Then I come over here. It's a 1-to-1. 1 mole of CO2 equals 1 mole of NaHCO3. Cancel, 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 cancel. Now how do I get 2 grams of CO2? I take 16 plus 16, which is 32, plus 12 is 44 grams of CO2 to 1 mole of CO2. And I go unit cancel, so I go 18 times 44 divided by 64.
12.38.
Is what?
12.38.
Yes. Come on.
Why did you round? Why did you round for most of the other elements except for carbon earlier?
Except for carbon, because carbon has that 0.01.
But the other ones have that point.
0.00. And when you round to 2 decimals, it actually becomes a whole number. You can, and when doing this, it's okay to round a little to make your life a little easier. So, and this equaled what?
12.38.
12.38. So, clear this so we have room. 12.38 divided by what I, flip those, sorry. Theoretical is 12.38. Actual is 5.6. So 5.6 divided by 12.38 times 100 equals
45%.
45%. The reason CO2 gas release has such a low percent yield is, think about it. The gas being released, it's hard to gather the gas. So that's why it is how it is.